Hello viewers. Today we will be solving the IB Math A HL November 2024 paper 2 question number 12. This is the last question of this paper. You will be getting the solutions for the first 11 questions of this paper and solutions for the other questions from the other past papers in form of playlist on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math EHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question 12. The maximum mark is 21. It says a curve C has equation y equal to 2x squared plus 6x minus 3 divided by x plus k, where x is a real number and x is not equal to negative k, where k is a real positive constant. Subpart E's question is show that dy by dx is equal to 2x squared plus 4kx plus 6k plus 3 divided by x plus k whole square. Okay, so let us start our answer for question subpart A over here. And dy by dx, we have to get this expression. Y is in the form of u over b. U over v. So we will be using the quotient rule. Okay. So y dash or dy by dx will be equal to u dash v. U dash means du by dx minus u v dash. V dash or v prime is again dv by dx over v square. This is the formula for the quotient rule. Okay. So therefore, what will be u dash? U is, let me write u first. U is 2x squared plus 6x minus 3. Therefore, u dash equal to 4x plus 6. Okay. Similarly, v equal to x plus k. Therefore, v dash or v prime is equal to 1. Okay. I'm not going into the details of how am I getting the u dash expression as this. Any student who is familiar with the basics of differentiation will be able to differentiate this expression to x squared plus 6x minus 3. Okay. So we have got the expressions for u dash and v dash. Therefore, we come back to dy by dx. Dy by dx will be equal to u dash. U dash is 4x plus 6 times v. V is x plus k minus u v dash. So u is 2x squared plus 6x minus 3 and v dash is 1. Okay. This whole thing is divided by v squared. V is x plus k, so it is x plus k whole square. Okay. So therefore, dy by dx is equal to, now we have to expand. It is 4x times x is 4x squared plus 4xk plus 6x plus 6k minus 3x squared, not 3x squared, 2x squared, sorry, minus 6x and plus 3 over x plus k whole square. Okay. So implies dy by dx is equal to 4x square minus 2x square is 2x square and 4xk, they have written 4kx, so I will be writing it as 4kx and 6x plus 6x and minus 6x, they cancel and you have 6k plus 3 over x plus k whole square. So shown. Okay. Now subpart B. Find the range of values of k for which a local minimum or maximum point exists. That means the graph or the curve C can have a single local minimum point or a single local maximum point, or there may be both one local minimum and one local maximum points. We are not sure of that, what will be the shape of the graph. But and we have to give the range of values. Okay, let us first of all see why does this matter to us? Why are we trying to find whether there exists only a single minimum or a single maximum point, or there are both one maximum and one minimum points? So, okay, first of all, what we know is for both minimum and maximum points, the dy by dx expression will be equal to 0. So, first of all, let us write that. Okay. So, for minimum or maximum, these are stationary points. I am writing minimum. I have actually written minimum. It is obviously the local minimum. Whenever we say minimum or maximum, they are nothing but the local minimum or the local maximum points. Okay. dy by dx is equal to 0. Okay. So, therefore, this expression should be equal to 0. 2x square plus 4kx plus 6k plus 3 over x plus k whole square should be equal to 0. And if a fraction value is equal to 0, that implies the numerator will be equal to 0. So, this implies that 2x square plus 4kx plus 6k plus 3 should be equal to 0. Okay. Now, this is a quadratic equation. And as I was saying that if you have a single local minimum or a single local maximum, then you will be having a single solution for this equation, a single value of x. That will be the x coordinate of the stationary point, minimum or maximum. But if you are having both a local minimum and a local maximum point in the curve, then you will be having two solutions for this equation. And since it is a quadratic equation, if you are having two distinct solutions, then the discriminant value should be greater than 0. And if there exists only a single real solution, then the discriminant value will be equal to 0. Okay, so that is why it is important for us to know whether there exists only a single stationary point or there exists two stationary points. Okay. By stationary points, I am referring to the minimum and the maximum, not the stationary point of inflection. Okay. So, one way to find out whether there exists only a single stationary point or two stationary points is to graph this. Because this is a paper 2 question, you will be having your calculator, and of course there is this variable k, but you can use the slider, okay, to graph. Let us graph this. Let us see whether we can get a single stationary point or we will always be getting two stationary points. Okay, what is the shape of the graph? So it is 2x squared plus 6x minus 3 over x plus k. Create a slider, yes. Okay. And you see the values for k, the default values are from -5 to +5, but the question says that k is a real positive constant, so we will not be having negative values for k. So let us change the setting. You press Control and menu, and this is the settings, and variable is k, value is 1. Okay, no problem. Minimum, let me take it as, I'm starting with 0 because it can be 0.1, it can be 0.01. So I'm taking the minimum value of k as 0 and let the maximum stay as at 5. Okay, let us see what happens. So this is the shape of the graph you see when the k value is 1. And as you are seeing, the graph is not having any minimum or maximum point. Okay. Okay, now let us change the k value. Now you are seeing there is a minimum point. Okay, let me change the window settings. I am just changing the y values. Y min, let me make it -20, and y max, it is +20. Okay, even now you are not having any, oh my goodness. So okay, let me take, at least you are seeing that there is a minimum point, but there will be another branch also for this graph. So let me just change the window settings and let me change the x min and x max also. So -20 and +20. And let this be equal to -30. Let's see what happens now. Now you can see this. This is the minimum point and this is the maximum point. Sorry, it's just the opposite. This is the minimum point and this is the maximum point when k value is equal to 5. And now again, if I go on changing the value, you see, when k is equal to 1, no minimum or maximum, 1.5, no minimum or maximum, 2, no minimum or maximum, going on, continuing. As soon as k is becoming 4, I am not sure, for 3.5 also you are having a minimum and a maximum point. For 3 you are not having. So it is between 3 and 3.5. For some k value between 3 and 3.5, you are starting to get one minimum and one maximum point. But for no k value, are you having only a single minimum or a single maximum point? Either you are not having any minimum or maximum point, or you are having one minimum and one maximum point. Okay. So we have now understood that if there will be a solution for this dy by dx equal to 0 equation, then there will be either two values, two solutions, where if there exists a solution, then there will be two solutions, or else there will not be any solution. Okay, not be any solution implies there will not be any stationary point, and two solutions imply that there will be one minimum point, local minimum point, and another local maximum point. Okay, so we are, and they are saying that there will be minimum or maximum points. So you will not be having the case where, or you are not interested in taking the cases for, or the key values for which no minimum or maximum points exist. So therefore, since we are interested in the cases where there is one minimum point and one maximum point, we will be taking the discriminant value to be greater than 0. Okay. So you can just write, you do not have to show the graph. This is paper 2. You can write using GDC graphs and the slider feature. We find y equal to 2x squared plus 6x minus 3 over x plus k has either no maximum or minimum points or no stationary points, or has two stationary points. Okay. You can find this because this is a paper 2 question and you are having the calculator. Okay. There are other ways also, but this is the easiest of all that I could think of. Okay. And now that we know that we are interested in this case that has two stationary points, therefore the discriminant value should be greater than 0. What is the discriminant expression? It is b square. B is 4k, a is 2 and c is 6k plus 3. So b square is 4k square minus 4ac. So 4 times a is 2 times c is 6k plus 3. Should be greater than 0. Okay. Implies 16k square and this is 8 times 6 is 48 minus 48k and minus 8 times 3 is 24. So minus 24 is greater than 0. I may reduce the coefficient, so it will be, I'm dividing the inequality by 8. So it becomes 2k square minus 6k minus 3 is greater than 0. So I don't think that it can be factorized. I'll be using the graph. Okay. So instead of k, I have to take x. So it is 2x square and minus 6x minus 3, enter. And you are having, this is a parabola of course because this is a quadratic expression and you are having two zeros, but this 0 is a negative value and k is a positive constant, so I cannot take this negative value for k. I'll be taking this 0. So menu analyze graph 0 and this one, it is 3.43649. Okay. And since it is greater than 0, we have to take the values of k for which the expression is greater than 0. That means the graph is above the x-axis. So it should be, k should be greater than 3.43649. Okay. So using GDC graphs, k is greater than 3.43649. So correct to 3 significant figures, it will be 3.44. Okay. Okay. Correct to 3 significant figures. Clear? So, k can be any value more than 3.44. You can take k as 4k as 5, any value. I have shown you the graph shape using the slider. So we are done with the subpart B. Coming to subpart C. Before that, consider the curve C with k value as 2. Subpart C's question is write down the equation for the vertical asymptote. It is containing just a single mark. So what will be the vertical asymptote? You have a vertical asymptote when the denominator value is equal to 0, and in this case k is equal to 2. So x cannot have the value of negative 2, because negative 2 plus 2 will be giving you a 0 in the denominator, which is not possible. So C x equal to negative 2. Okay, vertical asymptote. Subpart D, find the equation of the oblique asymptote. There will be an oblique asymptote regardless of what is the k value, because the denominator's degree is 1 and the numerator's degree is 2. Because the degree of the numerator is more than the degree of the denominator, therefore there will be an oblique asymptote. Okay, so for getting the equation of the oblique asymptote, we have to perform the long division, and the k value in this case will be equal to 2. Okay, so we have to divide 2x square plus 6x minus 3 with x plus 2. So 2x square plus 6x minus 3 divided by x plus 2. And for students who are not very familiar with the, you can of course use the synthetic division method also. But for students who want to learn long division, first of all, the denominator, the dividend, this is the dividend, it should be containing every power of x, starting from the highest power. In this case, the highest power of x is 2. So this is 2, 1, and this is the constant term, which is x to the power of 0. So you are having every power of x. If you do not have every power of x, one term with each power of x, you have to insert that term with a 0 coefficient. Okay. Then next we take the first term of the dividend and divide it with the first term of the divisor. So 2x square divided by x will be giving us 2x. And then this becomes the first term of the quotient, and we will be multiplying this first term of the quotient with every term of the divisor, and we will be writing the products below the like terms. So 2x times x is 2x square, and 2x times 2 is 4x. And then we have to subtract, so the signs will be changing. 6x minus 4x is 2x minus 3. Again, this becomes the present dividend, so I'm taking the first term of the dividend, 2x divided by the first term of the divisor, which is x. So the second term of the quotient becomes 2. 2 times x is 2x, and 2 times 2 is 4, plus 4. Again, we have to subtract, so the signs will be changing. And this one is minus 7 is the remainder. So therefore, we can write this as, because it is containing 4 marks, doesn't matter, we are required to give the equation of the oblique asymptote. You can just straight away say, therefore, the equation of the oblique asymptote is y equal to, you have to take the quotient expression, 2x plus 2. Now, so part E is question. Show that dy by dx is greater than 2 for x belonging to the set of real numbers and x is not equal to negative 2. Okay, and case value is 2. So let me just get the expression for dy by dx down. Now we have to prove that dy by dx is greater than 2 and k is equal to 2. So let us first of all rewrite this dy by dx expression. 2x square plus 4 times 2 is 8. 8x and 6 times 2 is 12. 12 plus 3 is 15. Over x plus 2 whole square. Okay, fine. So x plus 2 whole square. How to come to this 2? I can show that dy by dx is greater than 2 if I have dy by dx expression equal to 2 plus something. Then only I can prove that if this something is positive number, then only I can say that dy by dx value will be more than 2, definitely. Okay. So my target is to get the dy by dx expression in this form. Okay. So since the denominator is x plus 2 whole square, what if I can get something as 2 times x plus 2 whole square in the numerator? Then the x plus 2 whole square can be cancelled and I'll be having this number 2. Let us try that. So I need x plus 2 whole square. If you expand this, it will be x square plus 4x plus 4. So I have taken out 2 because I need 2 times x plus 2 whole square. So I'm writing x square plus 4x plus 4. This is what I need. So I'm just writing straight away this one, this expression. And 2 times 4x is 8x. Okay, it is fine. And 2 times 4 is 8. So I have added this plus 8. And since I have added plus 8, I have to add minus 8 also. Plus 15 divided by x plus 2 whole square. So this is equal to 2 times x plus 2 whole square and 15 minus 8 is 7 over x plus 2 whole square. So dy by dx will be equal to 2 times x plus 2 whole square over x plus 2 whole square plus 7 over x plus 2 whole square. So this is equal to 2 plus 7 over x plus 2 whole square. Okay. Since x plus 2 whole square is always greater than 0 when x is definitely not equal to negative 2. And 7 is a positive number. So 7 over x plus 2 whole square will be a positive number. And you are adding this positive number to 2. So the dy by dx expression value has to be more than 2. Okay. So therefore, dy by dx is greater than 2. I can write therefore 7 over x plus 2 whole square is greater than 0. Therefore, dy by dx is greater than 2. Okay. Shown. And So, but if sketch the curve C showing clearly both asymptotes, both means one is the vertical asymptote, another is the oblique asymptote, and the general behavior of C as it approaches each asymptote. You are not required to find any axis intercepts. Okay. 2x square plus 6x minus 3 and x plus 2. And you can get the 2x plus 2 curve at least. So tab 2x plus 2. So this is the oblique asymptote. I can show you the vertical asymptote line also, but in the exam mode, you will not be allowed to draw any vertical line. So I'm not showing that. So this is the graph that I have drawn. You can check with your calculator. And we have completed solving this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. It will be telling the YouTube that my video is worth watching, so my video's reach will be increasing. The YouTube will be showing my video to more number of students, so you will not only be helping me, you will be helping other students as well. So it will be a real help for me. And we meet again very soon. In our next session, we'll be starting to solve the EHL November 2024 paper 3. Till then, bye.